and welcome to Database Management Systems. I'm Chavita Christie, and in this video, I'm going to explain hashing as an index data structure in DBMS. Now, this is the instructor relation, and in the previous video, I explained that you could create an index on any particular column and then use it to search data within this table. And the only problem is that when you have to search for some ID, even though this is sorted, you have to search for each and every value. You have to try to compare your ID with each and every ID present here. That's the only drawback. Now I'll tell you what hashing is. So first of all, to perform hashing, you require a hash table, and it has some size. In the hash table, you will have some number of indices, and you will have some keys where you will actually insert your values from the column. So this is a hash table of size 10. Then you require some keys, and these are the keys that should be inserted into the hash table, and you require a hash function. The hash function is a formula that you will apply to the key in order to find out which index you should insert that key into. So that is what a hash function does in a hash table. Now let's see a simple example of hashing. So the keys to be inserted are 33, 45, 56, 12, and 19. And the hash function is key modulo 10. This is the hash table once again. Now we're going to insert these keys one by one. So the first value is 33. So we're going to apply the hash function, that is 33 modulo 10. Modulo gives you the remainder. So when you do 33 divide by 10, the remainder is 3. So that's what you get as a result of the modulo function. That means the key 33 would be stored at index 3. The next thing you have is 45. So again, 45 modulo 10 gives you 5. So 45 gets stored at index 5. Then you have 56, and 56 modulo 10 gives you 6. So 56 will get stored at position 6. Next you have 12, and 12 modulo 10 is equal to 2. So you will store 12 at position 2. The next thing is 19. 19 modulo 10 is 9. So you'll store that at position 9. So that's what a hash table looks like. And now we're going to see some hash functions. I already showed you one hash function, that was the modulo function, which is known as the division method, where you divide the values. So if you see the previous example, then the size of my table was 10 because it goes from 0 to 9. And that's why in the division method, the value that I used for division is 10. So it depends on the size of your table. If your table's size is 15, then you would be doing modulo 15, because only then would you get values between 0 and 14. So that is how this division method works. But there are other methods or other formulas through which you can define a hash table and you can do the insertions, and we're going to see those formulas now. So the types of hash functions are division method, multiplication method, mid-square method, and folding method. And once again, these are not limited to these 4. There are several hash functions available, and I'm only going to explain these 4. Out of these, I've already explained to you the division method, so that's why it's a little bit grayed out. Now I'm going to explain to you the multiplication method. So this is the formula for it. The hash function for a key, here the K stands for key, and Ka mod 1 gives you the fractional part of Ka, and A is again a constant value, which is a decimal point, so it would be something like 0 point something. And in this example, we are going to use the one suggested by a mathematician called Newth, and using that, we are going to find out the index. Now m here is the total number of indices in the hash table. So you can see here m, this is number of indices, k is the key, a is a constant value that you can select to be whatever you want. So we are going to take the value of a as 0.618033, and this is the value suggested by a very famous computer scientist called Donald Knuth, and that's why we're going to use this, because according to him, this value generates a very less number of collisions, and I'm going to explain what collisions are a little while later. So for any practical purpose, the size is obviously not so small as what we did in the previous example, because tables are really huge. So in this case, again, the hash table is 1000, size 1000, and the key is 1, 2, 3, 4, 5. So I'm going to perform those calculations on it now. So I've replaced all these variables over here with the numbers, and it gives me this value right here, multiplication. So it gives me a fractional part. Then I'm doing mod 1, and that gives me this particular part. And then I'm taking the floor value. And it leads me to 617, which is my key, which is my index. So I will be storing this key 1, 2, 3, 4, 5 at index 617. Now let's proceed to the next method. The next method is the mid-square method. So suppose you have a key 1, 2, 3, 4, then you are going to square this. So if you take a square of 1, 2, 3, 4, you will get 1, 5, 2, 2, 7, 5, 6, and I leave it up to you to check it out. Now out of this, what you're going to do is drop some of the numbers from the front and some of the numbers from the back. And once you've done that, whatever remains, suppose you want your hash table to be of size 100, then that means you need to pick a value that is less than 100 and greater than 0. So greater than or equal to 0. So in that case, you need to pick some value from here. And what happens in a mid-square method is you drop some of the digits from the front and some digits from the back, and try to keep 2 digits or 3 digits from the middle. And now since I want only 2 digits from the middle, I can either keep 22 or I can keep 27 because they are in the middle. And what you can choose whether to drop more digits from the left side or more from the right side. And I'm going to keep 27 out of this. So I'm going to drop the digits more from the left side than from the right side. So this is your index that is available to you. So you're going to insert that 1, 2, 3, 4 key in the position 27 in your hash table. The fourth type of hash function is the folding method. And folding method looks something like this. So if you are given a key 5, 6, 7, 8, you will split it into some equal number of parts. In this case, I'm choosing to split it into 2 equal parts, 56 and 78. Then you add those parts, and as a result, you will get 134. And 134 is the place where you will store that particular value. So that is the folding method in hash functions. Now the question is, how exactly does a hash table help in indexing? So the idea is you can see that the keys are not actually sorted. But the idea behind the hash table is that you're applying a hash function on the key and then obtaining an index. So when you want to search that key back, so for example, if somebody tells me now from this table to search for an ID that is 56, then I'm not going to start looking from the first position for 56. All I have to do is do 56 modulo 10, and that would return to me the value 6. And that just makes my job very easy because I got the index already, and I just have to go to the hash table and search for that particular index. So I got that index, and at that index I will find this particular key. So basically it makes your searching very, very easy. But there are certain problems within the hash table while creating it, and one such problem is collision. So in this example that I've given, what happens if I give you another key 76? We know that if you do 76 modulo 10, you are going to get 6 again. And the position of 6 is already full. So where would you insert 76? That type of a situation is called a collision. And we have to specify certain techniques in order to resolve that particular problem. So one such collision resolution technique is called linear probing, and I'm going to explain linear probing with an example right here. And here I've drawn the hash table in a horizontal manner, and that's all right. Hash tables can be drawn vertically or horizontally. It doesn't matter how you draw it. What matters is how you represent it within your system by writing a program, which we are not going to do in this video. Okay, so this is a hash table, again size 10, and we are going to use linear probing to insert these keys 72, 27, 36, 24, 63, 81, 92, 101 into this particular table. And so let's start with the first key, 72. So 72 modulo 10 gives you 2, so we are going to insert 72 in this position. You can see right here. As a step 2, we will insert 27. 27 modulo 10 gives you 7, so we insert 27 right here. Next, we insert 36. 36 modulo 10 gives you 6, so we insert 36 in the index 6 position. Then we have 24. 24 modulo 10 gives you 4, so we insert 24 in the 4th position. Next one is 63, and 63 modulo 10 gives you 3, so we insert 63 here. The reason why we are using modulo 10 is because it's a lot easier to explain than any other function, and so most of the examples will be using modulo 10. Next we are inserting 81, so 81 modulo 10 gives you 1, we insert it in the 1st position. Next, we're trying to insert 92, and 92 modulo 10 gives you 2. So what happens here is the position of 2 is already filled. Let me go and show you the previous step. So at the position 2, we already have 72, so we cannot insert 92. But in the technique of linear probing, we are going to probe further. So you're going to check the next one, and you will check, is the next index free? It's not. So go to the next one and check, is 4 free? 4 is not free either. And then we go to number 5, and you can see it's written -1. That means it is free. Nothing is there at the moment. So you can insert 92 at position 5 as shown in this particular step, 92 at position 5. So that is how you can resolve collision using linear probing. Now let's insert 101. 101 modulo 10 is again 1, and you can see that this position 1 is already filled. So you're going to do linear probing. You go to 2, 3, 4, 5, 6, 7, all are full, but you will find place in number 8. So you're going to insert 101 at index 8. So this is how we do collision resolution using linear probing. Now we are going to see another method of resolution, which is chaining. And in chaining, we are going to try and insert all these keys inside a hash table. And it contains 9 memory locations. That means the size of my table is 9. So the indices go from 0 to 8. So initially, of course, it's empty. Everything is null. Now I'm trying to insert 7. So because my hash table is of size 9, I will do modulo 9 and not 10. So modulo 9, 7 modulo 9 gives me 7 itself. And so 7 is inserted in this manner. 7, and then there's one more space for an address. In step 2, I'm inserting 24. So 24 modulo 9 means 24 divide by 9. And if you divide 24 by 9, what would be the remainder? The remainder will be 6. So we will insert 24 at position 6. Then we have 18. 18 modulo 9 is 0 because 9 multiplied by 2 is 18. So there's no remainder left. So 18 will be inserted at position 0. 52 modulo 9 gives you 7. So 52 we are inserting at 7th position, but we know that it is filled. But all we need to do is make a chain. So we attach it behind 7. So this is the address of 7. From here we attach 52. Next step is to insert 36. And to insert 36, when we do modulo 9, it gives us 0. So we attach 36 at position 0 right behind 18. So we are forming a linked list over here, a chain over here. And 18 will store the address of 36. Next is 54. Again, this gives us 0. So we attach it in the chain at index 0. Next value we are doing is 11. So 11 modulo 9 is 2. We put it at position 2. 23 is my next key, which returns 5 because 23 modulo 9 is 5. So we will insert 23 at position 5. So this is what chaining looks like. And there are several other techniques for collision resolution, but in this video I'm only going to cover these two, which are linear probing and chaining. And now I'm going to explain to you one last thing about hash tables, which is called rehashing right here. Rehashing or extensible hashing or dynamic hashing, it has several names. The only thing that you need to remember is that here you try to increase the size of the hash table. And when do you do that? When the hash table becomes nearly full. This is one reason. The second reason is when the number of collisions increases. That's your second reason. So based on these two reasons, if it happens, then you increase the size of the hash table. So let's see here. This is your hash table right now. It is of size 5 and already 4 keys are inserted into it. I know that now if I try to insert another one, I'm definitely going to have lots of collisions and I have only one space free. So when such a situation occurs, you will increase the size of the hash table, and by increase I mean you will double the size. So since this is 5, the double of 5 will be 10. So I will make it of size 10. Now the only problem is after I make it of size 10, these values will no longer be stored at 1, 2, 3, 4, because if they are still stored at 1, 2, 3, 4, then it would not match with my current hash function. They are stored here because I did modulo 5, because here my table's size was 5. But now I need to do modulo 10 because here my table's size is 10. So I need to rehash each and every key. So all the keys which are already present are again, for that again you perform the hash function and find out the new key. So for example, 26 modulo 10 gives you 6. So I'm no longer going to store 26 at position 1. I will store it at position 6. and the rest is easy for you to figure out. So this is what hashing looks like, and that's all for this video. Thank you for watching. See you in the next video.